So I asked you to complete, what was it, numbers 1 through 4?
No,
2 through 4. Oh, I did 1. Okay. So which of those caused issues? I'm happy to talk about any of them. Fourth one. Has everyone turned in what they have? Because this is kind of last call right here. Turn in what you have. It's better than nothing.
I messed up. I copied down the problem wrong. Did a completely different problem.
But you think you did that one okay?
I did that one.
Okay. I'll look at that. All right, so number 4, we have a function f of x equals x squared plus 4, and then x minus 3. All right, so we have to first figure out the left and right behavior. And to do that, we need to figure out what two things? The degree and the leading coefficient. So I told you that whenever it's already factored, this is kind of the harder part, but there's a short way to do it. Do you remember what I said to do? Yeah, you look at this like, I thought this was a different color. I guess not. Okay, so this one is really like an x to the first power. This one, you're going to have an x squared because, well, x squared. And then this one, an x. So if you multiply x times x squared times x, you get x to the 4th. And so you know that your degree is 4. The leading coefficient comes from just looking at the numbers in front of all those. Like you would get a 1 there, 1 there, 1 there. All of them have 1s. And so that would be 1 times 1 times 1. That would be positive. 1 times. So 3 1s multiplied, you get a positive number, right? So my degree is 4, which is even. And my leading coefficient is 1. Now, we also called the leading coefficient a sub n. That was the leading coefficient, and that's 1, and that's positive, right? And then we go to that little table, and we figure out what happens, and it's both sides up. And they all went both sides up, right? Every 1 through 4, all of them were both sides up. So I know that when I draw this, that's going to be my left and right behavior. Right? Now what we do is figure out what the x-intercepts are. So you set each of the factors equal to 0. What? Which one? This one? Looking at the numbers in front of the x's. 1, 1, and 1. Yes? Okay. So now, to find the x-intercepts, I'm going to set each factor equal to 0. So I set x equal to 0. I set x squared plus 4 equal to 0. And the last factor, x minus 3 equal to 0. So I have, well, this one, that's already solved, right? X is 0. That's one of my answers. I'll do this one. X is 3, right? Just move the 3 to the other side. This one's the tricky one because if you try and solve for x, you get a negative on the right side. And then you take the square root and plus or minus, and you get square root of a negative number. And that's going to give you an imaginary number. And we don't know how to graph imaginary numbers. We never talked about it. So what we would say here is there's no real solution, meaning that there's no point on our number line that I'm going to be able to plot for that. There are 2 complex numbers that are answers, but we're not dealing with those. So I only have 2 x-intercepts that I can graph. So that's what I do. I come to my graph. You cannot. That would be a different function. So those are the only 2. Now there's another thing we have to do. For each of these x-intercepts, we must find the multiplicity, right, in order to determine if we cross or if we touch, right? And the multiplicity does not come from the number itself, right? It comes from the factor that the number came from. So you have to go back up. Where did the 0 come from? It came from right here, right? What is the power on this factor right there? There's a 1. And since 1 is an odd number, I know I'm going to do what? I'm going to cross at that 0. And then at 3, this x-intercept came from this factor. And what is the power on this factor? 1, right? If there's not a number there, it's a 1. So again, that's odd, and so I'll cross. So I know I crossed through at both of these. And I know that the left behavior is that it goes up and the right behavior is that it goes up. So it's going to look something like this. It's going to go up on the right, up on the left, up on the right, and then it's got to come through cross and then come back through and cross and go up like that. So it's going to look like a parabola. Technically it's not a parabola, but it's going to look a lot like a parabola. Is that okay?
So we get the whole thing wrong if we include 4 x-intercepts?
Well, you won't get it completely correct, but you get it. You know, this was just an exercise just to get you all to do something and turn it in. And, you know, we were just getting our it's almost like a participation grade. Yeah. But I expected everyone to have a problem with this, all right, because I hadn't talked about that. So how do you deal with this? And that's why I'm addressing it. Okay? So I won't penalize you if you didn't do that correctly. All right, let's look at number 5 and 6 because we haven't dealt with those yet, right? And before I do these, I want to go back up in the notes. I forgot my laptop at home today, so I have to walk over here and scroll through these notes. There are actually a set of steps on how to graph polynomial functions that I skipped over because I didn't feel like reading through it would be worth us doing until after we did a few. All right, so here are the steps, the procedure on how to sketch a polynomial function. The first thing we do is make sure we're looking at a polynomial. And that's what we did when we graphed parabolas, right? First thing I said is make sure it's a quadratic function. And I actually had you determine if it was standard form or expanded form. Remember that? Okay, but in polynomials, just make sure you're looking at a polynomial. Determine the left and right hand behavior. So that's the table thing, right? Then find the x-intercepts. This step, why is everything bouncing? This step may require factoring, all right? Every problem that you did at home was factored already for you, right? So today we're actually going to have to do some factoring. In fact, it may require significant work to come up with a factored form of the polynomial. So we're going to start today with 2 examples that we should be able to factor. Then we're going to get to an example where we cannot factor it. And I'm going to have to see if I can convince you of a new way of factoring. We can find the y-intercept. Now, we didn't do that in the examples that I did, right? I just said plot the x-intercepts, get behavior. But we'll do it from now on. Y-intercept, we'll determine the multiplicities. We'll plot the x-intercepts and the y-intercept. We'll sketch it using the left and right behavior. We'll connect the dots with a smooth, continuous curve. Remember I said it had to be smooth and continuous. All right, so those are the steps. That's the procedure. So now let's look at number 5. Negative x to the 4th, f of x is negative x to the 4th minus 3x cubed plus 10x squared. And we're supposed to sketch this, all right? So is this factored already? No, all right, it's not factored, but we'll go through the procedure. Is it a polynomial function? Yes. All right, so we're going to determine the left and right hand behavior first. Now the good news is that when it's not factored, the degree and leading coefficient are easy, right? What's the degree of this polynomial? Degree is 4, which is an even number. What's the leading coefficient? -1, which is a negative number. And according to the table, when you have this situation, even and negative leading coefficient, what do we get? Let me just take a second to put, you should have this in your notes, even, odd, leading coefficient, positive, negative. So if your degree is even, you're here. If your degree is odd, you're here. If your leading coefficient is positive, you're here. If the leading coefficient is negative, you're here. So it's this one right here. So we know that this is going to go down on the left, down on the right, question mark in the middle, right? I forgot my question marks. All right. Now, factor. Find the x-intercepts. So for the x-intercepts, I need to set the function equal to 0, don't I? I mean, that's what you always do when you want to find x-intercepts for any function, right? You always set it equal to 0. And you may have to factor it, which in this case we do, right? So let's roll through the techniques of factoring. What is the first thing you always do when you're trying to factor something? Nathan? Greatest common factor. See if there's something that all terms have in common. You have a negative x squared or a positive x squared. It's up to you, but you prefer negative x squared because that will leave a positive on this first term once I factor it out. So if I pull a negative x squared out, right, all of them have an x squared? All right, pulling the negative out has the effect of changing the signs of everything. So what will I have left here? The first term would be what? X squared, then plus 3x, then minus 10, right? Minus 10. So it's changed the signs. And now you take a step back and you say, okay, that's fine, x squared's out there, great. This right here, right? This right here is a trinomial. It's 3 terms, right? Quadratic trinomial. So you try and factor this now. So you're doing just a mental, you're just comfortable to the point where you can do that mentally. Everyone in this class, since the beginning, I've been saying you need to know how to factor, and it's never going to go away, and all this stuff, right? Well, here it is again. You need to know how to factor that. So this step may take you some scratch work on the side, doing AC method or something like that, but everyone should be able to get from here to the next line. I wasn't lying. I was telling you the truth. You have to be able to factor a trinomial. Now it looks like we've got it completely factored, right? Like x squared, okay, fine. Here, that's a linear factor, x plus 5, and then x minus 2. We call that a linear factor also. So we've got it, right? There's nothing else for us to do. Set all the factors equal to 0. So how about this one? What do I do with that negative? Right here? You want me to set it equal to 0 first? Okay, I can do that. And then I'll set x plus 5 equal to 0. Then I'll set x minus 2 equal to 0. So I'm setting each of the 3 factors equal to 0. And then you were saying to get rid of the negative, just divide both sides by negative 1. Right, if I divide this by negative 1, I get x squared. 0 divided by negative 1 is still 0. Square root of both sides. So the only answer I get here is what? 0, right? Because the square root of 0 is 0. Plus or minus 0? Is 0 positive or negative? It's neither one, right? It's not positive, it's not negative. Yeah.
So you divided it by negative x?
Negative 1.
Negative 1.
Negative 1. Yep. Right here I just divided by negative 1, divide by negative 1. Negative over negative is positive. All right. And then the remaining 2, these are pretty straightforward, right? You get negative 5 and positive 2. So I have 3 x-intercepts. I'm going to determine their multiplicities right now. So let me go around. Jordan, since you look like you're ready today. 0, Jordan, is going to come from this factor, right? So what is the multiplicity, even or odd?
Multiplicity
Mm-hmm.
would be even.
You're looking at what?
Negative x squared.
Okay, so what part of, what is making you say even? The 0 or the 2? The 2. Okay, so this power is telling us that this 0 is going to what? When we get there, we're going to do what? Touch. So we're going to touch here. And then cross. We're crossing here because this 0 came from this factor. The power on that factor is 1. And then same thing on this one, right? Crossing here. Now, what we're going to do, in addition to the x-intercept, we're going to do the y-intercept also, which you didn't do when you did the take-home assignment. So how do we find y-intercepts? You plug in 0 to the function, right? So y-intercept, you plug 0 into the function. Don't set it equal to 0, plug 0 in, and this is going to be nice, isn't it? It's just going to be 0. And you plug 0 in, you get 0. All right, now we just put together the plot and put all our information, and then we're ready. We can draw it with a nice, smooth, continuous curve. All right, so I've got, on my x-axis, I'm going to have 3 points. Make sure you put them in order. -5, oh, let me put my y-axis here. -5, 0, and +2. You can put little dash marks if you want. I know those points lie on my graph. Also, I have a y-intercept, don't I? But my y-intercept is actually right here, isn't it? It just happens to turn out to also be an x-intercept. It may not always be this way, but in this problem it is. What should be the next thing I do in the drawing of this? Do my left and right behavior, right? So I know that it goes down, down. In the middle, I don't know. So I come in here with my pencil very lightly, and I imagine that over here on the left side, and when I say left side, I mean to the left of this point. Over here, it's got to be down, right? So it's going to be like down here somewhere. And then over here on this side, it's also to the right of this point, it's going to be down like that. Now I draw it with a nice, smooth, continuous curve, and I make sure that I cross through where I need to cross through, and I touch where I'm supposed to touch. So does everyone see I'm going to come up here to -5, and I am going to cross through, which is going to put me on the other side of the x-axis, right? When I go up here, I've got to come back, connect the dots, and I'm going to touch the 0. Don't cross through, right? Just touch it, and that'll force me back up. Then I've got to go back up and then cross through it too. That's it. Something like that. And remember, we also said last class that there could be different variations of this depending on, it's going to vary from student to student. So, you may have something that looks more like this, right? You may do something like that. That's fine. See, we don't care about these heights. That's calculus 1. But we should all have the same general picture, right? Okay. Questions? Sure? Okay? All right. All right, so let's look at the last one here, see how we're going to factor this one. 2x to the 4th plus 10x cubed minus 8x squared minus 40x. So the first thing I'm going to do is make sure I'm looking at a polynomial function. Am I looking at a polynomial function? All right. Then I'm going to look at the left and right-hand behavior. To do that, I'm going to look at the degree and the leading coefficient. I want you to do that yourself. And then Giovanna, does this open, which of these is it?
It opens up.
Like this? Up, up? So it goes up on both sides? Because your degree is what?
Even.
Degree is 4, that's even. Leading coefficient is 2, which is a positive number, right? All right, so that's why that's happening. And then, what's next?
We're going to find the
What's your name again?
Matthew.
Matthew. Okay, I didn't know that because I don't see any name thing, which is why I'm going to calling on you, and then I'll call on you, and then I'm calling all people without names. I'm starting to learn them a little bit, like a little, but
He's learning all the names that Joe don't.
yeah, trying to.
So we're going to find the x-intercepts.
We're going to find the x-intercepts, and how do I do that, Matthew?
Set it equal to 0.
Set it equal to 0? All right, good. I'll leave you alone now. Okay, Aaron, since you've been away for a while, I'll give you a break. I've already got Giovanna, so let's go to the next table. So if I call on you, you go ahead, you can introduce yourself. Say, hi, my name is... Oh, please do. Yeah, then I won't call on you. I won't call on you first. Go ahead.
Introduce myself?
Sure, because I don't know your name.
Stephanie.
Was it?
Stephanie?
Stephanie.
Yeah.
Hi, Stephanie.
Hi.
Stephanie, what would you do to set that equal to 0? Do you have any ideas of...
You take out the greatest common factor.
Okay, so what do you see as the greatest common factor here?
Can you do 2x?
2x, everyone agree? Okay, so let's pull 2x out. And do you want to keep going, or you want to tell me what would be in here? No, you want to move on? She's calling you out now. Go ahead, let us know. What was your name again? Gina. Hi, Gina. I feel like we should all say hi, Gina, like we're welcoming her to our group. The first step is to just admit that you're... Isn't that what you do, like when you're at like a help group? Like the first thing you do is like admit that you're... Like I admit I'm an addict. I'm a math addict. Okay, go ahead, Gina. What's left in here? Okay, so yes, what I'm saying is, what would be left here if I pull 2x out of every term here? What's left here, 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 here? Oh, hold on. You're going backwards. You're trying to figure out, what do you multiply this by to get this? So you have the 2 already. You have an x already. How many x's would you need? 3, right? 3 factors, x cubed. Plus 5x squared minus 4x minus 20. All right, so that's what's in here. And then I heard Gina say AC method, but do we do AC method if you have 1, 2, 3, 4 terms? What do you do when you have 4 terms? You try grouping, that thing called grouping. You remember grouping? So grouping is what we attempt to use when we have 4 terms. We're going to find today that grouping does not always work, right? But it's what you want to try first. So how does grouping work? Someone volunteer, because I wouldn't expect everyone. How do you do grouping?
You'll split it in half.
You'll split it right down the middle, right here, right before this sign. After the x here, before this sign. And then what?
Then you'll factor each side. So you can take that x squared out of both of them.
Okay, so I'm going to write the 2x. We're not even messing with that right now, right? Okay, you want to do a bracket? Okay, that's good. I like that.
And then you can take out of that right there, you can take an x squared out.
Out of these two, there's a GCF of x squared. So you pull that out.
Then parentheses,
Then your parentheses, what's left in there?
x plus 5.
X plus 5. Okay, Nathan, now I can tell you know what you're doing, but help me out here still. When I do grouping method, what do I have to have in parentheses here for this to work? I have to have an x plus 5 here also, right? So you need to be able to pull something out of both of these that would leave an x plus 5 here. So negative 4. If you pull negative 4 out, you'd be left with, well, x plus 5. Now you have to close your bracket off because the bracket was separating the 2x from everything. Does that look familiar to you all?
Yeah.
Yes, Stephanie.
I was taught differently last year where you can use the AC method. Can you or can you not?
Not on 4 terms.
Okay.
Yeah. I don't know, maybe...
I think I'm probably good.
You might be confusing it with something else, but anytime we have 4 terms, AC method won't work. You can use AC method to turn something into grouping. That's the way we do AC method, is you do that little table, you get your numbers, then you rewrite the problem as 4 terms, and then do grouping. So you might just be... Okay, so once you do this, what does the next line look like? Like, what can you do with the x? Hold on, Nathan. What can you do with the x plus 5 since they both have them? Go ahead.
Oh, you do isn't it 2x?
Okay, 2x, then
The bracket?
bracket or parentheses. I'll do bracket, that's fine.
And then parentheses x plus 5.
Okay.
And then parentheses
Mm-hmm.
x squared minus 4.
Yes, that is correct. And then close the bracket, right? That's what happens when you get the same factor here. The x plus 5 appears, gets factored out, and then you have the 2 pieces here together in parentheses. Now, do we really need the brackets anymore? No, because this is all multiplication now, right? So I'm going to rewrite what we have up here. Here's where we are. We have 2x, then in parentheses x plus 5, and then x squared minus 4 equals 0. So are we ready to do the thing where we find the zeros and multiplicities, or is there something a little more I can do?
Well, I mean, x squared minus 4.
X squared minus 4
Difference.
is a difference of squares, and we need to factor it completely. All right, so we need to rewrite this 2x times x plus 5 times x plus 2 times x minus 2 equals 0.
I mean, in theory, though, when you set it equal to 0, you would do the same thing and you get plus or minus 2.
Yes, the only problem with that is you may mess up your multiplicities. Like when you go back to get your multiplicity, what are you going to look at as your power to determine cross or touch? Out of here?
The factor is 1, right?
Right here?
Yeah.
But this is not completely factored. See, for the multiplicity, the factor you're looking at has to be linear in here, not quadratic. I don't know if that makes sense. It has to be completely factored out. So the story is you factor everything completely before you go try and find multiplicities. Are there any questions up to that point? All right, set all those equal to 0 now. Set each of those equal to 0. 2x equals 0. X plus 5 equals 0. X plus 2 equals 0. Oh. X minus 2 equals 0. And these are all pretty straightforward, right? 0, negative 5, negative 2, and 2. Do we cross or touch at these? All of them you cross, right? Because all of them have power 1, 1, 1, 1, right? They all have odd powers on the factors. So I'm just going to put C, 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 C for cross, 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 cross. So I have all the x-intercepts and their multiplicities. I'm almost ready to go. We did talk about the y-intercept, right? Trying to get the y-intercept just to help us with one more point on the graph. To do that, we just plug in 0, and we actually get 0 again, don't we? No. Just for these 2 examples, it happened to be. All right. Time to draw it. So I have an x-intercept at negative 5 over here, x-intercept at negative 2 right here, at 0, and at 2. Both sides of this went up, right? Both sides went up. So I know that it looks like this, and over here it looks like this. And I cross through at every single x-intercept. So it's just back and forth little roller coaster. Yeah. There we go. however you want. Crossing through at every point. Now, I've seen some instructors and some, even the tutors in the labs that say if you want, what you can do is you can pick some point in here and you can plug it into the function to actually figure out how low this goes. Like sampling, doing a sample point. And so let's say we plugged in, let's say -3, and it came out to be like -3 or something like that. The problem with this, and the reason why I don't tell you to do it, is because that does not mean that that's your lowest point. So you may say, okay, well, my graph's better because I know that that point's there, so my graph goes like that. And it could very well not at all do that. It could do something like this, where it goes like that, and then comes back up like that. So just having one additional point, to me, doesn't matter. Am I making sense? So just do what I've been doing. Don't worry about sampling other points. Okay, let's move on. There's a couple of more things at the end of this section we need to do. This time, we're going to go backwards. I'm going to give you the picture, and you're going to try and come up with a polynomial that would draw that picture. Now, let me first say that we can have all sorts of different answers for this, but we should all have general characteristics of our function that look the same. Do you all understand what I'm asking here? Like before I gave you f and asked you to draw the picture. Now I give you the picture yet, I'm asking you for f. So let's take a look at it. Think about it for a second while I draw it over here. So, Daniela, any ideas of, like, what are you thinking when you see this, Daniela?
There's no point for you to work backwards. Well, grab your points from there.
You want me to grab the x-intercepts from here? Or
Yes.
yes?
And I wrote down the y one as well.
You got that one. Okay. So you just wrote down all the points. Okay.
And then I came back over here.
You're looking at the left and right behavior. You know that it's what?
And I'm going to match it to an odd,
Odd,
but a positive.
positive leading coefficient. So do you all see? I mean, there's a lot of things that we can see from this. So that's all correct. It's just how are we going to organize this into a final function, right? So let's just talk about each of these things. I have an x-intercept at -1, don't I? And it touches, which means that the factor this comes from must be raised to an even power. Understand? This x-intercept of 2 crosses, which means that the factor that it comes from must be raised to an odd power. Yes? The fact that the left side goes down and the right side goes up means that my degree must be odd and my leading coefficient must be positive. Right? And then finally, this point right here tells me that when I plug in 0 to the function, I should get -2 to come out. Do you agree? All right. So let's try and put that all together now. I always am going to tell you to start with the x-intercepts. Okay, so if -1 is a 0, is an x-intercept of the function, then what is the factor it comes from? So if I have an x-intercept of x equals -1, that means that I must have a factor of what? X plus 1, right? Agreed? Because how would you get -1 from a factor? You'd set it equal to 0 and you'd get that, wouldn't you? So we're working backwards. In addition, because it touches there, I know that the power on that has to be even. Yes? And it's my choice now to make it 2 or 4 or 6 or 8. That's why I'm saying everyone's going to have a different answer here. I'm going to pick 2. Why? Because I don't want to make this more complicated than it has to be. So I'm going to put a 2 on it. So that I know right now is part of my function, right? The other part that I have an x-intercept of x equals 2, which means that it comes from a factor of what? X minus 2, right? And since I crossed there, sorry, right? This needs to be an odd, so I'll use 1, which I don't need to write it, but that's what I'm going to do. Everyone okay with that? All right. Now, just if we start right now to put our function together, I guess I'll do it up here. This is what we have so far. F of x equals, I'm going to leave a space here in the beginning. Just leave a little space also, and I'll show you why here in a second. That's what I have so far, right? I know that my function contains this factor and this factor, right? When I look at this right now, what would the degree of this be? What would the degree of the whole thing? This is going to act like what? What does this whole thing act like? X squared, and this one acts like x, and that would be like an x cubed. So I would have an x cubed, wouldn't I? Which I need, right, for it to behave the right way. And I would have a leading coefficient here of what? 1, right, because these have 1s on them, which is a positive leading coefficient, so that would work, wouldn't it? So everything so far is perfect. But I also need this y-intercept. So let's try this. If we plug 0 into that, do we get negative 2? So you plug in 0 here, what do you get? What's 0 plus 1? 1? 1 squared? 1. Okay? Plug in 0 here, you get negative 2. What's 1 times negative 2? Negative 2. And that's exactly what we have, right? So this actually works. Yes? Okay, so this would be our answer. No, but that we got way too lucky that worked, right? Do you agree? We got way too lucky. So yeah, just for the sake of showing you how you would do this if it didn't work out that nice, I want to change this right here to a negative 4. Can we do that? Change this to a negative 4. And imagine that this was negative 4. Does that change any of the other information in the graph? No. No. The only difference is this, right? But I know now if I plug in 0, I'm not going to get negative 4 out, right? So what we do in general, the reason why I leave this space is we like to put here c, which is some number we don't know what it is yet. Right? So if we're going to try and figure out what c is, try and follow me here. Well, that's what it's going to turn out to be, a positive 2, but let's see how. All right? So every time you set these up, always get your factors in here, get the correct multiplicities and stuff, put a c here, and then go to this information. When you plug 0 in, you need to get negative 4, right? So I'm going to write this down. When I plug in 0, I need this to be equal to negative 4. That implies, now have you ever seen that double arrow before? This is called an implication symbol. It implies, so that symbol is, like if I write this, if x equals 2, then x squared equals 4. Does everyone agree with that statement? If x is 2, then x squared is 4. Do you agree with that? Another way to write this is x equals 2 implies x squared equals 4. That's another way of writing this. All right? So this is what we call a forward implication. If you say that this is equal to this, then that means, right, then that implies that what? This c times 0 plus 1 squared times 0 minus 2 must equal negative 4. Right? Isn't the left side of this right here this? And the right side of this is this. We already figured out what this was, right? This was c times 1 times negative 2 equals negative 4. And just multiply 1 times negative 2 times c is negative 2c equals negative 4, which means c must be 2, dividing both sides by negative 2. You're just solving an equation for c. Do you all see this or not? Yes? So it's kind of like we created the function, but we realized we might be off a little bit because of the y-intercept. We needed to figure out how to adjust this c so that I can make this graph fit exactly here. And so I determined c this way, and now I go back and I replace this c with 2, and that's the function. I'm getting some looks of,
I have a question. So say we saw, like, just from the get-go, we saw
that it was 2?
that it was 2, right?
Well, that's
And we
okay.
had everything and you wanted us to sketch it. When it comes down to it and you find your x-intercepts and your multiplicities, there's no powers on 2, is there?
There's not a power on this 2?
Yes.
Yeah, there's not a power on
Okay,
that 2.
so 2 would equal 0 and then it'd be like no solution.
No solution, correct. Yes, this would be a factor, but when you set it equal to 0, it would not contribute to anything because it's not, yeah. It would, well, just 2 doesn't equal 0. So. Everyone agree that's the function? We could box that up and be done and we'd be happy. But we could also multiply it all out, couldn't we? Like you could do, like foiling that out and then multiplying it all together. And all you would have is just a different version of the function, not factored. But I won't ask for that. This is good enough. Okay. Last example, I believe. Oh, there's one more thing right there. Construct a polynomial function with these characteristics. So this is the same exact thing that we just did, except I'm not giving you a picture, I'm just giving you information. So I'm giving you that you have to construct a polynomial. It has zeros that are -4, 5, and 1. Now don't forget, zeros are the same as x-intercepts, all right? It has a degree of 3. And it has a point on the graph of 2, -18. So let's start again with the zeros. What does -4 being a 0 mean that I have? X plus 4 is a factor. 5 being a 0 means x minus 5 is a factor. And then 1 being a 0 means x minus 1 is a factor. So I know I have those 3 factors. So the function that I have so far, I'm going to put a c here because I don't know what c is going to be x plus 4 times x minus 5 times x minus 1. Now, let me ask Jalen, right? Yeah? I didn't look at your name tag. I got that right, though. Okay. Jalen, what about the multiplicities on these? What do you think? They're all going to be 1? Why? That's right, because the degree is 3. See, we're already at a degree 3 polynomial here, aren't we? If I try and, because you might be saying, well, do I cross or touch at these? If I touch here, I have to square that, right? But then this becomes a squared, a first power, and a first power. That's 4 powers. That's degree of 4. I can't have that. So the maximum I can actually get here is what I'm looking at. Does that make sense? If someone had put 5 here, well, then you're free to do whatever you want with this. You could make this one squared, and it would, what, that wouldn't be 5. Let's not change. Don't change it on your paper, but let's say this was 5. Couldn't I do this 2 and 2, right? But I could also do 2 and 2. I could also do, what, 3? And, well, I'd already have 2 here, like 1 here and 1 here. So do you agree that if that was 5, everyone could have way different answers? Yes? But it's not, it's 3. So we all have to have that answer, right? No one can deviate from what's there. So we've taken care of this information. The only thing left is, yes?
So that's why people can have
If this were a different degree. In this case, we don't. Yeah. Yep. Now, the c, though, we have to determine. So think about it this way if you can. We know that this thing hits the x-axis at -4. We know it hits at 1. We know it hits at 5, right? Agreed? We know it's a degree 3 polynomial, which means that it looks like this or this, right? There are infinitely many polynomials I could draw that are degree 3 that go through these points. I could draw this. I could draw this. Hell, I could draw this, right? I could come up from the bottom. There's infinitely many that cross through at each one and still behave like a degree 3, either that way or that way. Because I don't know what the leading coefficient is, do I? Not unless I have this information. See, this information is going to lock down exactly one of those pictures because it must pass through this point. Do you see that? So I'm going to use this information to figure out what that C is. If the C turns out to be positive, it was one of those. If it turns out to be negative, it was one of those. Understand? So let's figure it out. So I'm using the point 2, -18. Doesn't that mean that f of 2 equals -18? Isn't that what this means? When I plug in 2, I get 18? So let's now write this down, right? Replacing every x with what? 2. So c times 2 plus 4 times 2 minus 5 times 2 minus 1. That must equal what? -18. And so, look at this. You have an equation, right? And the only variable in this equation is c. So you'll be able to solve for c. What is it? C times 6 times -3 times 1. I'll just put parentheses around that. Equals -18. Oh, come on. Seriously? All right, so that's going to be c is 1. Right? -18c on the left equals -18, c is 1.
He seems so disappointed.
I was hoping it would be something a little more exciting, like 1/2 or something. But it's just 1. So our final answer is that with just a 1 here, which means you don't need to even write it.
Which means we're locked into that bottom.
That means that the leading coefficient is positive,
Oh, that's right.
right? So it's one of these, but it's actually, there's only one now. There's only one graph that you could draw. This one, yes. But I'm saying we couldn't deviate from it. Well, okay, let's just leave it alone. Okay. Does this all make sense?
Yes.
Okay, the general idea of sketching a polynomial, it requires that you can find x-intercepts, multiplicities, draw, right? If I give you the other information like the picture or just general information, you should be able to go backwards and generate the function. So where does this become difficult? If this is kind of straightforward, then where does the difficulty arise? When I give you a test, I give you a problem that you've never seen before. No. No, we have to actually spend the next 2 days talking about how to deal with a difficult situation. So let me bring up the next section. So look, I've been teaching college algebra for a long time, and there's no approach in any textbook that I really care for. So I kind of have my own way of doing this. So I'm calling this Chapter F for factoring. All right? We are going to do something that's not in the book. It's a combination of several sections in the book. All right? So what I'm going to say is for homework, you will not touch anything until I tell you for R4, R6, okay, R4, R6, which is on your schedule, don't worry about that homework until I tell you to go do it. I might tell you today, but I just don't want you going and trying to attack it unless I say, okay, you can do it now. All right? All right, so sometimes we run into polynomials that we can't factor. So I'm going to give you one up here. x cubed plus 8x squared plus x minus 42. So if my instructions to you were to sketch this, right? If I were to say, hey, go ahead and sketch this now, everyone would be like, okay, great, great. I've got the degree is what? Odd. Leading coefficient's positive. You know, it looks like the top right here, right? The left side goes down, right side goes up. You'd be in business. Then you get to the x-intercept part. You'd set it equal to 0, right? So let's just skip to that part. We get to the x-intercept part. We set this equal to 0. And then we see 4 terms, right? Well, GCF. Is there a GCF? No greatest common factor. We see 4 terms, so we start thinking, okay, grouping, right? So we try and we split this right here, and then we look at the first 2 terms. We try and pull a GCF out, which we have, right? X squared. And you're left there with x plus 8. And then over here, in order for this to work, what do you have to have in parentheses over here for it to work? You have to have an x plus 8, which means you have to be able to pull something out that would, when you multiply it back through, give you this. It's not going to happen. There's no number that you're going to be able to come up with, right? Right here, plus. There's no number that when I multiply it through, I'm going to get back x minus 42. Do you all see that? So what would you normally say in this situation in like another class, not this class? You'd say it's not factorable, or you'd say it's prime or something like that, right? They would tell you you can't factor it. We would give up, right? I mean, we would just kind of wave our hands at it. Does everyone understand? Okay. So we're stuck with grouping. It doesn't work. But no, by the way, I'm doing it different than the book. This isn't like my own method or anything. It's just the way that I'm presenting it is different than the book. I want you to look at, can everyone see the very bottom of this? You see those 3 terms on the bottom? I'll write them down on the board. I'm just going to write down x plus 2 times x plus 3 minus 2, thank you. X plus 7. All right, let's multiply these together, okay? I'm not going to tell you where I got this. I'm just going to ask you to multiply these out. Forget all that for a second. So if you were to multiply these out, people have different ways of doing this. I would recommend that you always start with these 2 first and then do your like little FOIL game on that. So this would be equal to x minus 2 and then times, let's see, x times x squared, x times that, 7x plus 3x plus 21. Collect your like terms together in the parentheses. And that's what you would have, right? Then you multiply, to multiply these 2 together, how do you do that? FOIL, but FOIL doesn't work because, okay, so all need to make sure we have a technique for this. Go x multiply through to every term, and then after you're done with that, the negative 2 through to all the terms. So we're going to have a total of 6 multiplications. And I'm going to write that down right up here, okay? What's x times x? X cubed. X times 10x. 10x squared. X times 21. 21x. Okay, negative 2 times x squared. Negative 2x squared. Negative 2 times 10x. Oh, wait. Did I do that one? No. That's negative 20x, right? And then negative 2 times positive 21 is negative 42. Collect your like terms together. Well, that's the only x cubed I have, right? And then how many x squareds do I have? 8 x squareds? How many x's do I have? 1 and then number 42. So this is that, right? But how do you go from here to here? Grouping didn't work, and grouping was the only thing that they ever taught us how to do, right? What? Do you know what it is? Do you know how to do it? Okay. No, so the whole point here was for me to try and convince you that there has to be some way to get from here to here, right? But it's not grouping. It's something else. And so what I have to do now is I have to spend the next class developing the technique to get to here, all right? It's going to take a little while to do it, but once we have it, it's actually a brand new way to factor. And it's very powerful. And I think they should teach it as the first way to factor, but they don't. So everyone on board? I'm just trying to sell you on the idea that it can be factored. We just don't know how to do it. All right. All right, so what we need to do now is we need to kind of clear our heads a little bit, remembering at the end of the day that that's what we're trying to go for, is to be able to break something like that down. So I put in here, yeah, so how in the world are we going to factor this? Division tells us a lot about something, all right? So we are going to take a look here at just old school division for a minute. When I sit here and I write something like 15 divided by 3, everyone in this class says 5, right? And with that information, you could also have written, what do I have up there? That 15 is equal to 5 times 3. So if you have something divided by something else, and you get a nice answer, that means that the bottom here times this equals the top there, right? The one below it is the same thing. 60 over 2, you get 30. But that, I'll use the double arrow again, implication. That implies that 60 is 30 times 2. I'm not trying to insult your intelligence. I know you all follow that, but again, it's baby steps leading up to this. But what about this? What if I change this to a 4? Does that go in evenly? It's a decimal, right? It's not a nice answer necessarily. It's not a nice whole number. So this equals something. I actually don't know exactly what it is, but it's something, right? It's like 3 point something. But it's not easy for me to say what it is. So I know that 15 is 4 times something, but again, I'm kind of like, I don't know, right? So what we like to have with division is, if we're going to use division to rewrite it as multiplication, then we like for that to be a nice answer. Yes? Okay. So now let's take a look at x squared plus x minus 2 over x plus 2. All right, let's take a look at this. Instead of using 15 divided by 5, right? Instead of 15 over 5, I'm writing a polynomial divided by a polynomial, yes? Okay, so how do we do this? Hold on, I'm thinking of how I want to lead you into this. Let's first just look at what this should be as an answer, right? Like, what should this be? If I take the top and factor, take the top over there and factor, you get x plus 2 times x minus 1, right? Over x plus 2. Isn't that what you get if you factor the top? And then these two factor, and then what's your answer? X minus 1. Yeah? That's what we should get. Hold on a second. I want to make sure I don't feel like walking back over there, so I have all my notes right here. I just want to make sure I follow the format of the notes. All right, so that means that if this equals x minus 1, right? That's